let's go ahead and find the vertex. We'll review. So we have our formula, which is negative b over 2a. This particular problem will have negative 8 over 2 times 1, which is negative 8 over 2, which equals negative 4. So the axis of symmetry is negative 4. Still need to find the y value. We just know that if we were graphing right now, that, okay, the vertex is somewhere on x equals negative 4. All right, somewhere on this nice vertical line. So f of negative 4 would be negative 4 squared, negative, plus 8 times negative 4, minus 5. So we get 16 minus 32 minus 5, which equals negative 21.
Yes.
So it's really somewhere way down below. That's the vertex. What's the x-intercept? I mean, sorry, the y-intercept. Yeah, we know the y-intercept is negative 5, so maybe we get 1 point on either side. So if I had to do a rough graph, that's a good way of doing it. But try not to do it correctly all the way. So we have a equals 1, b equals 8, c is negative 5. 1, 8, negative 5. So I can go down to 1, 8, and negative 5. And just as we expected, the vertex is way down here at negative 4, comma negative 21. The y-intercept right here at negative 5. Whatever c is, that's the y-intercept. And our roots are, yeah, pretty close to that. So, next, let's actually go ahead and complete the square on this. Let's go ahead and complete the square. So, first thing we do would be to, move the 5 on the other side. So we have x squared plus 8x equals positive 5, right? Set it all up. That's what we did yesterday, or 2 days ago actually. Set it all up. Half of 8 is 4. 4 squared is 16, both sides. And 5 plus 16 is 21. Stop there. Any observations about where we're at right now? 4 and 21. What's our vertex? Yeah, I think that's a coincidence.
I think not.
So, today we're introducing that halfway through the completing the square, the vertex actually shows up, which can be quite useful if we need to graph and find the x-intercept. So, what we can do is that we're going to actually, instead of square rooting both sides, we're going to move the 21 back to the other side. So now we have y equals x squared, x plus 4 squared minus 21. And this is called vertex form. Now you'll notice, by looking at this, it's not exactly the vertex, because the vertex is actually negative 4. So recall that every time it's inside the parentheses, it was always the opposite sign. Even when we were doing absolute value of like x minus 4, that meant the graph moved to the right 4, not to the left. You think, oh, minus 4, that should be over here, but really it was the opposite. So even back in the last chapter, if it was inside parentheses, absolute value, or if this was like a step function, it did the same thing. It always moved the graph the other direction, the positive direction. So when we look at this form, we just have to be careful and know that it's always the opposite sign. Okay, it's always the opposite sign. So if we look at this, we want to say, oh, yeah, the vertex is at -4, -21. This one stays the same, doesn't change. It's just when it's inside. Okay, and then we're also sometimes going to have some number in front of the parentheses, our a value. But this is called vertex form. It's kind of like the equivalent of slope-intercept form. It's running in standard form, right? When you did linear equations, you had something like this: 2x plus 3y equals 6. And you did this to both sides, and you got y equals mx plus b. This is like the equivalent of slope-intercept form for quadratics. We're going to do something, instead of like subtracting 2x and dividing by 3, we're going to complete the square of quadratics halfway. Not even halfway, almost, well, just 2 steps. And then we're going to stop, move the number back over, and that's called vertex form. So that's really what we're going to be practicing today. It's just doing vertex form. Now, if the question also asks, solve, we could actually just rewrite this, take the square root of both sides, and get our 2 answers as well. Like on this one, it would be -4 plus or minus the square root of 21. And that gives our 2 roots. So if we have to find both the vertex and the roots, it looks like completing the square is the fastest way. It is the fastest way to do that, because it has finding the vertex within the same problem of finding the roots. All right, just got to watch out for that opposite sign. All right, so let's do a few practice. We'll do another one all the way through. So we have x squared minus 18x plus 85. It all starts off the same. X squared minus 18x, leave a space, move the 85 over, we're at -85. Set it all up just like we did yesterday. Finish it up. Let's see here. Half of -18 is -9, -9 squared. Both sides, same thing. And what do we get? -4. Bonus question. What type of roots would we have if we solved this? If we did solve it? 2 complex, because the next step would be taking the square root of both sides, and we'd be taking the square root of a -4. Yeah. So instead of solving though, we're going to move it back over. Move it back over. So we have y equals x minus 9 squared plus 4. What's the vertex? Very good. So everybody caught it. +9, 4. Opposite sign for the x, same for the y. +9, 4. Bad. Go ahead and try on number 2. You can duplicate the process. Alright, you might have something like this. Leave space. -9. Set it all up. X minus 4 plus 16 plus 16. 16 minus 9 is 7. Positive. And then move it on over. x minus 4 squared, and then minus 7. That's y. If you really weren't sure and like, I don't know about this, confirm it. X sub b is negative b over 2a. Negative b is 8 over 2 times 1. So you get 4. Yeah, vertex is 4. Same thing you got here. Vertex is 4. Positive 4 on a negative 7. So always the opposite sign of from inside the parentheses. So you could confirm it, do a little small calculation just to make sure. Alright. So you remember 2 days ago we spent a whole day on, well, what if there's no number in front? It's just a 1. Alright, so those are the ones we just did. What if there's no number in front? Pretty simple. Okay. So yesterday, that's when we looked at like 4, 5, and 6. 4, 5, and 6. And write them. When there is an a value in front. So it's going to be slightly different in this way. Go ahead and watch this one. First step, same. Okay. Leave a space, move it over. Here's where it's going to be different. Since this is y equals, and y equals means we're like graphing it, you can't just divide everything by 2 and say it doesn't matter. Because when you're graphing, it does matter. You'll have a different graph if you divide everything by 2. The roots will be the same, and that's why when we're finding roots, we can go ahead and divide by 2. Because even if we divide everything by 2, the roots are identical. But for graphing, it's not a completely different graph, but it's a different graph. So we can't just divide it out and say it doesn't matter. So instead, we're going to do factor it out of these two. Factor out whatever number is in front of the square term, positive, negative, whatever number is in front of there, we're going to factor it out instead. So we have x squared minus 2x, right? Leave space. And now we're going to complete the square backspace. So more or less the same. Instead of just dividing out, we're going to factor it out. Set everything up like we normally do. And bring down the 2. Now that 2 has to stay there. Has to stay there. So complete the square. Half of negative 2 is negative 1. Negative 1 squared is 1. Here's the thing. On the left-hand side, what did I just add? Now, I added 1 on the inside of the parentheses, but there's a 2 on the outside. So I really just added 2. I added 2 times 1. If I distribute this, I just added the 2. So over here, I actually have to add a 2. So whatever these multiply to, I have to do on the other side. Instead of just being the same thing. There's a number out front. So it's a kind of same but different. Negative 3. Now the nice thing is the vertex is still these two numbers. Okay, so let's go ahead and move back over. There we have 3x minus 1 squared minus 3 y equals and the vertex is still just the numbers on the inside. So a nice thing about this vertex form is if there's a number on the outside, it still doesn't change it. It's still at, what's the vertex? Yeah, positive 1 comma negative 3. Yeah. Positive 1 comma negative 3. Alright. Not too bad. Little same, a little different. We just have to watch out on here. There's a number on the outside, multiply those two together, and that's what you add right here. That's why it's a 1 here, but it's 2 over here. You have to multiply those together. And it will be set up in the way, like on number 5 and 6, you see how a 3 goes out of these perfectly? 2 comes out of these first 2 perfectly, so you don't have to worry about any practice. All right. Well, your homework. Time is so it's going to end up. Okay, so a little time. Anyway, your homework's going to be just do a few of these. And this is really just looking at the equations and saying, what's the vertex? This isn't even doing the whole process. I just want to give you a heads up on them. And this is a little review right here from the review section. We're probably looking at a quiz or a group quiz on Friday. So heading towards, we're at the end of the line. One more, try it with me. Try this with me. So we have 3x squared plus 3x. Leave space. Move it on over. We also have to factor this. Whatever numbers from x squared, positive or negative, we have to take that out. So take out a positive 3. Number x squared plus x. Some number. Equals -5. Now complete the square. So half of 1 is 1/2. Okay with this? And what goes here? 4. Simplify it. What's -5 plus 1/4? Or did that one? Sorry. Yep, thank you. I missed myself. Oops. I didn't focus on the time. 3 times 1/4 is 3/4. Yeah. 3/4. So -5 plus 3/4. -4 and 1/4, which is let me know. What is it?
17.
-17. And add it to the other side. So, hey, it works nice even though it might be some ugly numbers, it still works. We can get the vertex, no problem. So we have 3 times x plus 1/2 squared plus 17/4. That's the way. So our vertex is at -1/2, comma, 17/4. But today, on this homework, it's just going to be really looking at the equations. And you might notice some that have like a -2 in front, x minus 1, and then plus 4. It's really just looking at it and saying, the vertex is at where? 1, comma, 4. That's what really, and there's only a few, like 5 of these. So this whole thing will take maybe 10 minutes. And then if you feel like you need to study for anything else from the completing the square quadratic formula, keep that in mind. You'll have a good quiz coming up not too long from now. All right. That's it for today.